All right, guys, here we go. Some more dilation fun. Now, as I said in the last video, you can see right here, I'm using a different letter for scale factor because truly it doesn't matter. Like here I used K for scale factor. Here we're using R for scale factor. And because it's less than 1, this is going to be a reduction. So we will get smaller. And I think the word reduction is pretty obvious, like implied that it is smaller, but we'll just make that little note right there. So if my pre-image right here is at the point, A is at -3, 3, and then B is at -3, -3, and C is at 3, -3. And then I'm just going to reduce it all by a third. So like take a third of all of it, or really divide by 3. A prime will be at -1, 1, because a third of 3 is 1. B prime will be at -1, -1, and C prime will be at 1, -1. So everything just shrinks in. So A is at -1, 1, or A prime rather. B prime is at -1, -1, and C prime is at 1, -1. So hopefully like that makes sense to you. Like, and the other thing too is it kind of changes location a little bit. Like I've noticed in the past that some students get a little bit confused by that. And the thing is, you almost have to think of the dilation happening from the center, right? From my origin center. So like if I'm going from here to dilate out and make bigger, it's going to kind of push the shape out a little bit. Versus if it's already big and then I'm going to dilate and shrink it in, it's going to smush in and get closer to the origin. So not only is it going to smush in size, it will also sort of get closer to the origin or further away, depending on if you're getting bigger or smaller. So it's not like it just gets sucked into itself, because it's really getting sucked into the origin. So it's going to get closer to your origin. And the other thing that I can notice as well, that these side lengths all reduced by a third as well. Like this was 6 units long, and now it's only 2 units long. So that's good as well. So staying on the reduction, let's open this up and try this one out here. So we have our triangle. A is at 3, 1, 2, 3, 4. Oop, -3, excuse me. B is at -3, -3, and C is at 2, -3. And so then if I want to take half to reduce by half, we're going to get some not so nice numbers, but they're not terrible. Like half of 3 is just going to be -3/2 or -1/2. But half of 4 is good. That's 2. B prime will be -3/2, -3/2. And if you want to call it 1.5, like I get it, we're graphing it. That makes a little bit more sense. And then C prime, half of 2 is 1, and then -3/2 or -1.5 again. So if we go to graph these, excuse me, A prime will be at -1.5, 2. So again, you can kind of see how it's getting smushed in closer to our origin. B is at -1.5, -1.5, so right in the middle of a square. And again, it got pulled in to that origin again. And then lastly, C is at 1, -1.5, so right here, C prime. And again, like when I count the length of the sides and everything, like that should also get smaller by half. So like this side length is 1, 2, 3, 4, 5, 6, 7. So it should be 3.5 units long now, and it is 1, 2, 3.5. So that's kind of fun and cute. We can also do it to a quadrilateral or a rectangle. So if I find my pre-image points, D is at -3, 4, my goodness. E is at 3, 4. F is at 3, -4, and G is at -3, -4. I am getting smaller. 3/4 is less than 1. So personally, I like to divide by the bottom number if I can, and then if not, I just multiply the top numbers. So like for D prime, I can't divide by 4 here, so I'm just going to get negative 9 over 4 because I multiply the top numbers. But the second one, the 4s will divide out, and so it's just 3. E prime, I can't do the first one, but it is the same number as the last one. Did I get goofed up on some of these? Oh, no, I didn't. Okay. So it's still going to be 9/4, just positive now. And then here when I divide, the 4s go away and it's just 3. And kind of they're all the same point. I just need to make sure I have the negatives in the right spots. So negative 3 here, and then negative 9/4 and negative 3. Because again, all the numerals are the same. It's just the signs that we got to get straight. So like every time I multiply, they're going to be the same. And this is just going to, again, reduce. It's going to get sucked into the middle. So D is at negative 9/4, which is like 1 3/4. So negative 1 and almost 2. Oop, and then up 3. 1, 2, 3. D prime. And then E prime, we're at 9/4, which is 1 3/4, and then up 3. And like this makes sense to me because they're only moving in a little bit, and 3/4 is just a little bit smaller than 1, so it's not going to shrink a whole ton, like just a little bit. And so F prime will be at 1 3/4, comma negative 3. And then G prime, we're at negative 9/4 and negative 3, so right there. And so again, it kind of gets smushed into the middle. This time it does feel like it just smushed in on itself, but that's because it is originally like centered around the origin. Like it's not just on one side or the other of the origin. That's why it feels like it just got pulled into itself versus this one that's kind of like, you know, to the left of the origin a little bit. So like it doesn't just smush in on itself, if that makes sense. Alrighty, talking about an enlargement now. If my shape, or if my scale factor rather, is bigger than 1, it will enlarge or get bigger than the original. So for instance, if I have D at negative 1 comma 1, and E at negative 1 comma negative 1, and F at 1 comma negative 1, if I enlarge everything by 3, I'm just going to multiply everything by 3. So D prime will be at negative 3. 3, is this just the opposite of the one above? I think it is. E prime is at negative 3, negative 3. And then F prime is 3 comma negative 3. So negative 3, 1, 2, 3, comma 1, 2, 3. D got pushed out, D prime rather. And then negative 3 comma negative 3 for E prime. Again, got pushed away from that origin. And then 3 comma negative 3. So I'm glad actually that I recognized that this one was the same as the top one, because it just really reinforces the fact that we need to label everything correctly. Like we need to make sure that we are labeling our points with our primies, because if I'm looking at this without any labels, it's the same. It's the same image, but they are different because like we started with big and got small, and this one we started with small and got big. So that's why it's super important to label our pre-image points and our image points. Alrighty, so if we now do a scale factor of 2.5, if we write out our points, H is at negative 1 comma negative 1, J is at 2 comma 1, and I is at 2 comma negative 1. Since it's bigger than 1, I am enlarging, so it will get bigger by 2.5. So H prime will be at negative 2.5 comma negative 2.5, because we're just multiplying by 1. J prime, 2.5 times 2, oh my gosh, if I double it, that's just 5. That's 5, duh. And then 2.5. And then I prime is 5 comma negative 2.5. Okay, so then we go plot those. So H prime will be at -2.5, comma -2.5. So we're right in the middle of the square here for H prime. And then J prime, we're going to be at 5, comma 2.5. And then I prime will be at 5, comma -2.5. Now, this one is a really good one to point out the fact that my right triangle should still remain a right triangle, even though it's larger. And again, it did get pushed out, which that was going to happen. But it's still a right triangle. And it needs to be because it is going to be similar as the first shape, or similar to the first shape. So just because you're dilating it, it's not going to change like the general form. It's just going to make it bigger or smaller. So hopefully that kind of makes sense. Like kind of with this one here, this rectangle is going to start a small rectangle, but it needs to end a big rectangle. Like it shouldn't magically change to a parallelogram or something, or a trapezoid. And again, we are enlarging because this is bigger than 1. So K is at -1, comma 2. L is at 1, comma 2. My goodness. M is at 1, comma, we're going to assume that that's right in the middle of the square. So 1, comma -1/2. And then N is at -1, comma -1/2. And now we're just going to double all of those points. So K prime is going to be at -2, comma 4. L prime will be at 2, comma 4. M prime is going to be at 2, and then like 2 times half, or half of 2 is 1, but it is negative. And then M prime will be at -2, comma -1. And then we just go plot those bad boys. So K prime, we're going to go to -2, comma 4. And again, it should get pushed out a little bit because that's what a dilation does. L is at 2, comma 4. But it should still maintain that rectangular shape. M is at 2, comma -1. And then N is at -2, -1. So N prime right there. We redraw our rectangle. And we can also see too, like by the lengths of the sides, like this is 2 and now that's 4 units long. So that got doubled in length as well. Cute. Dilation's super easy.